good morning to one and all present over here. Today we are going to see about feature engineering, which is one of the most important thing while developing a machine learning model. First of all, let us see what is the feature engineering. Feature engineering is the process of creating some new features whichever is needed, or transforming whatever is already existing in order to improve the performance of our machine learning model. For example, it involves the process of selecting some relevant information from the raw data. Otherwise, we may convert or derive something from the existing data. Something like if I have the date of joining in any one of my organization, then I can able to retrieve easily my experience from the data. Like that, if an experience is needed for developing the performance of my machine learning model, then I can include one new feature there by utilizing my raw data which is already available. Such a kind of process is called as a feature engineering. The main important goal of this feature engineering is to improve the accuracy of our machine learning model, so that we may get the exact predictions or classifications whatever we are trying to do with our own application. And this is the raw architecture whichever belongs to feature engineering now. First of all, I am having some raw data. That raw data is already having some features. Where I am going to implement the feature engineering is, I am trying to apply some rules or some kind of combinations, or I am going to apply some deriving kind of information to the raw data, so that I can able to add the new features, or I can able to remove some features whichever is not really needed at that time, so that I may help my model to improve the performance there, so that as a result I can able to get the more accurate data. And we will see what is the feature. Feature is nothing but it is an individual measure, property, or a characteristic. We can call it as anything. It may be a data point. So inside your data set, that data point is a very important input for a machine learning algorithm. So as we all know, if it is a data point, that it may belongs to any kind of a category. Like it may be a numerical data, or it may be a categorical data, or it belongs to some text kind of a data. For example, if I am having something like a data set which is comprising information regarding the housing prices, then I may have the following things as my feature. The features are nothing but the number of rooms in the house, or number of bedrooms available in the house, and what about the square feet, the location, and the age of the property, like the building is 7 years old or 10 years old or 50 years old, like that. So age of the property may also be one of the feature. I'll give you one more example in order to predict the proper meaning of a feature. If I am looking for a data set of a customer demographics, demographic is nothing but the basic details of a customer. So that you may have some features like age, gender, or income level, the location, their address, their PIN code, like that. Okay, some of their biometric data. So all these things will constitute a feature now. We'll try to provide the purpose or the need for feature engineering now. Why this is really needed for a machine learning model is because it will improve the user experience. Because whenever we are working on a project, whenever the time progresses or my machine learning application progresses, I may need some new features to be added, or I may identify some features whichever is really not needed at that time. So in order to improve the user experience, it is really needed to perform the feature engineering for my dataset. Also, it will provide the competitive advantage. See, myself and my friend both are developing the same application. If I apply feature engineering, then I can able to optimize the model, so that I can train it to provide more accuracy by eliminating the unwanted things or by adding the needed things. So it will provide the competitive advantage. So since it is user friendly, definitely it will meet all your customer needs. And also, if a model is really powerful or popular, then it will going to increase the revenue generation also. One of the most important thing is feature engineering really focusing on the future needs. Like what will happen if I am having some more data added inside my data set, like that. So future proofing is also possible with the help of feature engineering. And here comes some set of process involved in the feature engineering. These are called as the phases of feature engineering. Here we are having some 5 important phases of feature engineering. The first thing is feature creation. My second phase is feature transformation. Third process is feature extraction. And my fourth one is feature selection. And the last one is feature scaling. See, all these phases constitute a thing called process of a feature engineering. The entire process is going to follow this flow. First of all, you have to create a feature, then if needed you have to transform it, otherwise you have to extract it from the existing features. You may select the needed features as per your specification, then you can able to go for feature scaling also. That is, I may either scale up or scale down. Depending on my need, I can able to do this. My next thing is, let us see all those phases in a brief manner now. The first thing is regarding the feature creation. See, feature creation is nothing but, first of all, I have to know, like I should have some minimal knowledge about the application or the domain, whatever I am working on, so that I can able to provide some guesses like these are the features really needed at this time. So in order to create a feature, we should know something about the domain. Domain knowledge or observing the patterns, whatever already existing in the history is very, very important in this space. Like you are having some types of feature creation. Like first one is domain specific. As I have told you, this is purely based on the domain knowledge we have. And this is regarding the data driven. Data driven is nothing but, suppose if I doesn't have any domain knowledge, but I can able to observe the data pattern or I can able to understand what is already existing in the data set, then I can able to derive something from the existing one. Such a approach is called as a data driven feature creation. And my last one is synthetic. Synthetic is nothing but I can able to combine the features which are already existing. That is, the combination of something may provide some useful features to me. So these 3 are the ways of feature creation. I repeat, my first one is regarding the domain knowledge, second one is regarding the data driven approach, and the last one is regarding the synthetic approach. See again, why feature creation is, this is a very generic advantage, like what is provided by the feature engineering. The main goal of this feature creation is, I am supposed to increase the accuracy of my machine learning model. Let us see what is happening in my phase 2 or the second process, like feature transformation. So we all know transformation is nothing but I am trying to convert the representation of a data or the form of a data into a useful manner. So that is called as feature transformation. So if I want to convert the data from one representation into another, I am having some types over here. My first one is based on normalization technique, second one is on scaling, third one is on encoding, and my fourth one is the simple transformation here. Normalization is, I am trying to bring all the data into one particular range, like starting from 0 to ending at 1. So I am going to normalize all the things like that. And my second thing is regarding scaling. As I have told you, I can able to either scale up or scale down. Based upon my necessity, I can able to do such a transformation here. My third one is encoding. Encoding is nothing but I am trying to convert my categorical data into a numerical data. That is converting from one type to another. That is called as encoding based transformation. So these 3 are the important ways of a feature transformation. So again, why feature transformation is the same thing. In order to achieve the main goal of increasing the accuracy of the machine learning model, I am trying to go for this process. And the next thing is feature extraction. While the starting of the class itself, I have told you what is an extraction. I am going to extract something from the raw data which is already existing in the data set. I can able to get new data from the existing data. That is called as extraction. So for such a feature extraction also, you are having some techniques of machine learning here. Your first one is dimensionality reduction, second one is feature combination, third one is feature aggregation, and my last one is feature transformation. Dimensionality reduction is nothing but I am trying to increase or I am trying to reduce the number of features by transforming the data set into I am trying to reduce the number of features so that I am not supposed to lose any data by reducing the number of features here. That is more important. Since I am trying to increase the accuracy of data, I am going to remove or reduce the unwanted features without any data loss. That is the important point we have to consider here. My next thing is regarding feature combination. It is association of already existing features. Feature aggregation is I am accumulating the features to create a new one. And the next one is regarding feature selection. Feature selection is I should have some knowledge about relevant features and the irrelevant features based on the specification obtained from the customer. That is called as feature selection. So for such a feature selection, you are having some important types again. Like you may apply the filter method. Filter method is I am going to filter data based on some categories. Otherwise, I can go for wrapper method. Wrapper method is I am trying to find the subset that results in the relevant features of myself. And my last one is regarding the embedded method. Embedded method, see, this is little bit advanced. This will be the result of a training methodology or the strategy, whatever I am applying for my data set. So, based on that strategy, I can able to extract something as the output. So the last phase of this feature engineering is feature scaling. Feature scaling is nothing but I am trying to bring the available data into a similar scale. Like I am going to bring all the data within a range of either 0 to 1 or in the scale of minimum to maximum or in the scale of robust method like that. So that is what we used to call it as a scaling. To perform that scaling, you are having three important types. One is called as min-max scaling, second one is standard scaling, third one is robust scaling. Min-max scaling is nothing but it starts from the minimum value and it will end with the maximum value. Standard scaling is nothing but it lies from 0 to 1. Your minimum is indicated with 0 and the maximum is indicated with 1. If anything lies beyond 0 and 1, it is called as the deviation. Your last one is called as the robust scaling. Robust scaling is nothing but here we are trying to find the outliers and trying to divide them from the relevant feature to the irrelevant subset. That is what we used to call it as feature scaling. So this is the gist of a feature engineering, which actually comprises of 5 different phases. Thank you.